Thank you. If you don't mind, I stay here. It's okay? So I have the difficult task now to come from the air traffic controller perspective into that, where on one side we are extremely intrigued by what's going on outside ATM, but we are also extremely worried that we are still talking about the same issues we have been talking 20 years ago. So you still have HF radios over the ocean while the people in the back are tweeting or Skyping. So maybe we get a question on the fora, internet fora, from somebody who is crossing the Atlantic. But the pilots in front are still doing exchanges by HF radio, which is of old and obsolete technology. So that is for us a little bit the issue of how do we actually imagine our future. And I'm going to try to, if you can move on, I'm going to try to show you a little bit. I have also put that down in a written contribution. There you will find a little bit more background information on what we have published on what we think is the future. We do not talk about the specific solution. We talk about, sorry, if you can come back. We talk about the new aerodrome tower concept. And we don't limit it just to the remote towers. This is just one of the examples. But we could very well imagine that we go back to what Russia was doing in the past, that you actually have a person at the end of the runway with a green pistol saying to the pilot, you can take off. And all the departure and landing clearance are being given by an approach or departure center. So that has been done for many, many years. So, or we have also now new solution like the redundancy tower in Heathrow, which is used or has been built by the company who is running currently Heathrow somewhere, but it is for a dedicated purpose. So here, maybe also just look a little bit into the future, what we expect from this new aerodrome tower concept. Next slide. Thank you. So what we have done once the global air traffic management operational concept has been published by ICAO, which we have been part of the drafters as well, we have tried to translate that into an operational world. What does that mean for the controller Lambda or the controller from Geneva, IAM? What is written in this conceptual vision for the future? And that has given us if you can come back, sorry, maybe it goes ahead without, yeah, sorry. Makes me speed up what I want to say. So this statement is on internet. You can see we have actually tried to really imagine what is meant in the global concept, how that could be translated in an operational environment. And that is quite important because we still suffer, and that has been mentioned before, we still suffer from the fact that we work on the structure and not on the technology. We have been always, in the past 20 years, we have been working on structure, on institutional structure, on legal structure, on technical structure, but the technology has not really evolved in the same pace as we have been doing our work. Where you see, you just saw an iPhone before, or an iPad, or the Android phones, when you see that, technology is completely overtaking structure, and that's what we are struggling with, particularly also in some issues of liability and so on. So we are in between. We would like to see something like an application for air traffic control on an iPad in the future, but we are still stuck with some old technology, which is the reality, but has also some advantages which have been mentioned this morning. It's secure, it's consolidated or concentrated inside. Next slide. So what we then have said, for us, the future of ATM will look like this. So the whole ATM system will be performance-based, and changes will be based on performance cases. That means a business and a safety case will lead to a performance case. If it's too expensive but extremely safe, you don't do it. If it's not safe but extremely cheap, you don't do it. So that is the trade-off already for the future systems. We believe that the high level of automation will be required in order to meet this ATM performance. By the way, nowadays we have only few elements of air traffic control which are automated. So there's still a huge challenge for industry and also for research to become active and to give us some solution. Air traffic control currently is reactive and tactical, should be replaced by more proactive strategic. The idea that the intervention will still be there, but the intervention will be different one, and it will be time-wise a different one, maybe even geographically a different one, but also certainly the importance of the intervention will be changing. It will be management by trajectory, but I come back to that. Airspace will be dynamic. So for the time being, we have huge issues as well, legal issue, but also population issue, land planning issue. When you talk about classification of airspace, how do you protect the airspace? How do you free it up? How do you use it as a barrier, as a safety barrier? All these things. In the future, we should come to a solution where we have an airspace we actually can adapt to the type of operation we will be doing. So imagine that you start with a stream of traffic in Sweden or in the Scandinavian country going to Spain. You would then offer that to the best price air NSP, air navigation service provider, who can offer that service for that day. Well, that means then also maybe you adapt the various degrees of service you provide to these aircrafts. UAV and non-segregated airspace, that we believe will be the future. There will be less controller needed, maybe not in number, but in some sort. We believe that a controller will become more productive. And I'm one of the lucky guys who is working in one of the most advanced centers in Geneva, en route center. And just to give you an example, it's a local example, I know, but when we moved from paper strip to no strip anymore and lists with assistance tool, we were able to offer 26% more capacity. So what constituted for me in the past a red zone where I started to come to my personal limit was a strip bay with 19 aircraft. Now my counter, I have a counter in my sector, is normally, when I'm approaching now my personal red limit, okay, I'm becoming older, so maybe it goes a little bit down, is around 26, 27, 20 aircraft at any given moment. So this is what we believe, that we will need the same number of air traffic controller we most probably have currently in the system, but they will work more traffic. That's what we foresee. And then we have regional, local implementations where we call virtual tower, remote facilities, and also completely automated separation provision. I don't want to do that in the future anymore. The system should be having so much computer capability that they can do that on themselves with scenarios established. But of course, there's a lot of research to go into that. Next slide, please. What we believe the future airport operations will be as well, they will be much more stringent than today. They will be based on 4D, they will be based on auto land, on auto takeoff. There will be no more margin for interpretation. So that means the 4D starts once you close the doors, the 4D starts with the pushback, and it ends with the takeoff. However, that means also, because we are absolutely not used to the operations like this, that if you fail to meet the agreed target of a trajectory which leads you from the gate till you are in departure phase, that you lose your slot. That means you go back and then we negotiate it again. That is also something, the price to be paid. And in the future, we believe the airport operations will have to give us daylight reproduction, whatever weather it is. So low visibility procedure should not be an issue anymore. So that is maybe a little bit of dreaming, but that's how we imagine that the future will look like when it comes to airport operation. Next slide, please. And then here comes the reality of a profession. So the professional reality is, I've chosen elephants. There are more animals later on, but we're still in air traffic control. But I think that's to show that as a professional organization representing a global membership, we have different issue, and when some of our policies comes up, these policies need to be also put into a global context. But here you have, for example, what we believe in any future concept should be a minimum recommendation, a minimum standard before you move any further steps. So that means the controller shall have the same level of surveillance. There should be no, compromise in order that he can look into at an airport for visual separation. So it's very, very challenging technologically speaking, very expensive technologically speaking, extremely expensive, but that should be for us a condition sine qua non. Also, what we hope that we will be able with simulators to match the safety level so that we can show that the new concepts which will be introduced are meeting the same safety levels as before. And of course, that we are associated to all this and the contingency procedure should be in place. Again, when you automate things, you can then not rely on the human operator who has been de-skilled, retrained, changed to do something. So if you have an elephant and the camera doesn't see the elephant for whatever reason or another animal, well, that's not good. That's not good, sorry, that doesn't work. And then don't ask the human operator to intervene in a scenario which is not planned. Next one, please. We talk also about reproducing a visual reality. So we have been talking about CCTV. I took another animal here, but it's a strange one, so that's from the sprayer Banksy, who did that on a CCTV camera. Again, we are asking for the same level of surveillance. That means the same level of representation, which can be maybe even enhanced by the use of new technology, infrared cameras and things like this. Next one, please. There are other animals. So for us as well, it should be clear, so the concept should not be adapted. So actually air traffic control on the surveillance area. So we need to be clear that we don't have to change suddenly the runway layout, suddenly to have adaptation of taxiways and things like this in a way which would not assist the controllers who are there to do their job. And I think that's the one on the remote towers, if you can move on. So we have the remote towers. I used the slide of the children's tower in Brussels Airport in Zaventem to show that I imagined the NATS redundancy facility like this. I've never seen it, but it's not like this. So, but that there are maybe different solutions to this issue. If I have a little time, I'd like to introduce the I4D, and for that I have used a rabbit, which is the I4D is being talked about as being the magical solution, but as we just heard before, it has been around. You can once more. It has been around for quite some times, we believe all the times. If you can click on, as explained very well before, what we actually are very poor on the ground is we don't know where the traffic is in the next second. We know where it has been in the last second or in the last 4 seconds, but we don't know where it is in 1 second, and we do not know where it will be in 10 seconds, in 10 minutes, and things like this. So that we hope in the future we will be knowing, because we can rely on things which have been on board. So if we continue, what we believe is that trajectory management, when we talk about trajectory management, it has always to be in 4D, it's four-dimensional. It cannot be neither 2D or 3D, which some people advocate that could be a solution. So it has to be all the 4 components, and it has been around for many, many years. It has been around. If you look at some of the operations over the North Atlantic, you actually can fly unrestricted. You fly unrestricted. You want the level, if it's free, you fly. And you can stay as long as you want up there. There are restrictions, and the restrictions are the community members. So you might have a military zone. You might have another air traffic, traffic. You might have weather. You might have restrictions, performance restrictions, that you cannot land if you don't have track miles onto your airport. So you have to descend. Things like this. And as we say here, it has been offered quite long. So we know exactly what we think it should be, based on this experience we had already. So even nowadays in continental airspace, you will give any direct route. The only condition is that it remains legal. So you have to call your friends, your neighbor, that it remains safe, so free of another traffic, and things like this. But then you can have actually system in place which work already in form of night network or direct route or free route concept as they're being called. Next one. What is important, however, if we talk about I4D, and that has been mentioned by Nicholas as well before, the FMS trajectory is not the same as the ATM trajectory. And if you look at the I4D trials which have been made, that helps industry very much to improve the precision of the FMS, but it doesn't help the ATM community because we need still to know what we're going to do with this precision now suddenly in the system, and we have to actually bring in some sort of freedom, tolerance, all these things we need to build in. So there we are still very weak on the ground. And as I said before, when we talk about the moving airspace, we actually imagine that in the future we will be able to build on what we have in the oceanic areas and also bring it into a more continental airspace. The one major stumbling block we foresee is the precision of the weather. The precision of the wind, because you need wind, otherwise wind readings precise, also turbulence model, otherwise this whole concept cannot operate to the precision needed. On the North Atlantic you have 10 minutes between two traffic following each other. In Europe you need a precision to do I4D trajectory as foreseen in some of the César work packages of 3 or 4 seconds, and currently the FMS producers are about approximately confident up to 30 seconds, but not closer on the whole trajectory, not just on a given point in a simulator and things like that. So these are certainly challenges which need to be looked into it. And we foresee that it will have a huge benefit in continuous descent and continuous climb operation. Next slide. I have shown that, okay, it's a funny one, but the computer asks you for restart in a very crucial phase. So that is of course a redundancy issue. Can you continue with the slide? So we talk about a contract, and I have explained before what we believe will be, at least in aerodrome operations, the future. That means there will be an agreement, time and location, and that will allow as well to become much more stringent on the strategic level. And it can be modified, but there will be protocol, service level of agreements to do that. And as I said, the weather is one of the most challenging ones. Next slide. I'm coming to an end. Here is a very, very busy slide. I'm going to show that to you tomorrow as well again. These are the questions we have for the lawyers. So, who is responsible for the decision of automation? Who is responsible in case of failure? And what is if the failure is more damaging? What do we do with commercial off-the-shelf products and their certification? If we use what-if tools, so if a machine tells me, turn him left, it's much better, and I think, oh no, I turn him right, but I follow the machine and something happens. And remember, I will not separate aircraft anymore. I will only intervene if the machine has conflicts, several conflicts where I say, I need to talk to the human. I need to talk to the guy, and he will know what decision to take. So he proposes a few what-if solutions. I click on one, and it fails. Who is responsible then? It's not, at least for us, it's not obvious. Delegation of separation. Is the system liable? Can the system be held liable? What about if one of the platforms, the airborne platforms, loses the prediction function? What do we do with that? So there are minimum precision and prediction functions which have to be built in. What happens if that goes wrong? And if we have runway occupation time, that's also ROT, runway occupation time. It's not just remotely operated tower. There's an established 4D contract, and it's not, for whatever reason, it's not followed. What do we do? So things like this, a lot of questions. Also, if we really believe that there will be dynamic airspace, if there comes some legal liability issues, if an accident happened, German controller controlling a flow of traffic somewhere in Spain, and so on and so forth. So a multitude of questions. But I said the last part I will reserve for tomorrow when I talk about the human and automation. And I have also put in a runway status light, because the current use of runway status light is, yes, very nice, but if you want to have a remote tower, that cannot just be a sensor and a runway status light, because it needs to be much, much more. And that is something we currently also need to look into it a little bit further. And the question is, I think, yeah, go on. The question is also, are we ready for all this? Are we really ready? Do we really want to go there? Because with all the questions we are asking ourselves, is this the way to move? Or should we not be a bit more humble and say, okay, we're doing a job which is not too bad. We need to improve, but if we go way above, then maybe we limit ourselves. So these are questions we are asking us towards the more legal and judicial community. Thank you very much.
Thank you very much.